can easily crack it.
Yeah,
Yeah,
the
let's
rotting
try.
orange one really a good problem. I felt like uh,
Mm-hmm. Yeah,
the
yeah,
flood feel and the rotting orange are kind of similar, but
yeah,
with slight variations. Yeah,
yeah, true. Okay. So you can see my screen, right?
yeah.
Okay. So let's understand the problem statement. You will be given an array, okay, and the limit. So let's say the array is something like uh, 10, 1, 2, 4, 7, 2, and the limit equal 5. So you will be given an array and the limit. Return the longest subarray. In that subarray, if you pick up any two elements, the difference between those two elements is must be what is it, less than or equal to the limit. Okay. So let's say longest subarray. For example, if you pick up yeah, if you pick up these four elements, 2, 4, 7, 2. Okay, so you pick up these four elements. It's a subarray, na? It start subarray means what? You start from the index, you just continue it. So you don't skip any elements in the middle. Even 2, 4 also subarray, and 2, 4, 7 also subarray, and 2, 4, 7, 2 also subarray. So something like that. So what's the problem is you can pick up other subarrays also. You can pick up. Let me quickly draw a couple of them. One is 10. 10 is a subarray. 10 1 also subarray. So 10 1 2 also subarray, and so on, starting with 10. Similarly, 1 is also subarray. 1 2 is subarray. 1 2 4 is subarray, and 1 2 4 7 is a subarray, and 1 2 and so on, starting with 1. Similarly, starting with 2 and so on. So I'm just writing a couple of them. Now if you closely see, these are the subarrays we could make. These are the subarrays we could make. So what's the point is, you can pick up, so you in a subarray you can pick up any two elements. The absolute difference between those two should be less than or equal to 5, because you also given limit. If you see here, it has you need to pick up any two elements. So in this case, definitely this is not the case. If you pick up these two elements, the absolute difference is 9. So here also the absolute difference between 1 and 2 is 1, but when it comes to 10 comma 1, right, which is 9, so it is invalid. This is also invalid. Similarly, this is valid, so because the absolute difference is 1. This is also valid because here it is 1, here it is 2, so at max the absolute difference you could see 2, so that this is also valid. This is valid, but if you closely see, when you compare 1 comma 7, so 7 minus 1, which is 5, which is 6, which is greater than k, so that this is invalid. Similarly, if you closely see this one, right, I could see the max absolute difference you could find is 5, so which is less than or equal to given limit, so that this is valid. So we need to return longest. This is also valid, this is also valid. If you closely see, here you get 2, here you get 3, here you get 4. These three are valid. We need to return longest subarray, so that is subarray length, which is 4. Is the problem statement clear, Ajay?
Yes, it's clear.
Now, how do you try? How are you trying to approach it?
So basically, we need to find subarrays where the maximum number minus the minimum number in that subarray should be always less than equal to the limit value.
Mm.
Correct.
Correct,
Okay.
correct, correct. So that's the thought. Let
Mm-hmm.
me. But how do you do that? How do you know that the current subarray is valid or not? What is a brute force solution? What is a brute force solution?
Brute force solution would be find the subarrays
Mm.
and find the mean and max,
Mm.
and where the difference of the mean and max is less than equal to limit,
Mm.
consider that as a solution.
Yeah, perfect. So what is the time complexity?
That's gonna be thing n square.
Yeah, so definitely n square, right? If you write a pseudocode, so this is our for starting from 0 to
Hmm.
n minus 1. Then you will have for j starting from I plus 1 to n. So, right, so somehow you will move on. So here you will find min and max. You will figure out min and max here. So through this, then finally what you will do, once you have a min and max, you can find max minus min if it is less than or equal to limit, absolute difference you can say. If it is less than or equal to
Hmm.
limit, so the length is going to be j minus I plus 1, because you are starting from 0. So whichever is max, you will just consider that. Correct?
Hmm. Hmm.
So
Yes.
you will max comma whichever is max you will consider out of this. So that's our length. So it's a purely n square solution. Now how do you? What are the What are the? What is the mistake we are doing here? So what is the space complexity here? It's constant,
If you're
right?
just taking a count, then constant, yeah.
Just a constant. Okay. So what is the mistake we are trying to do here?
Here, basically, we are iterating over every possible subarrays.
To know minimum and maximum, right?
Yes, yes.
To know minimum and maximum. Mm, how do you avoid that?
I think by taking our Q,
Don't forget about Q. Q solution is very optimistic. Before that, how
okay,
do you want to do it? So there are.
okay,
So first of all, we need to know min and max, right? Both, right? So we need to know min and max of current window, right? Correct, nobody?
yes, yes, yes.
Current window. So if you want to know min, but here the problem is the min and max is taking n times to find out min and max for each iteration, which is going to take n times. So
Mm.
that's why it is causing n into n, so which is leading to n square. But somehow I need to figure out min and max of a current window. That's what the current window is, right? Like something you are extending the I pointer, right? Each time. So initially it is 0, then 0 1, starting with 0 and keep on going on, starting with 1, keep on moving on, and somehow you will figure out. I think you need to apply this logic somewhere here. While doing brute force, rather doing at last all the time, you can check here.
Mm.
Just a minute. Yes, that way you can and one way is you need to optimize it. So one way is uh, okay. So you can think about brute force, but some this logic doesn't work straightforward, but some optimization is required. So what is the optimization you could think of when you're writing brute force? Uh, if you find a max, yeah, max minus min difference, if it is greater than k, then you don't need to explore further subarrays starting with this, right? You can stop there
Correct.
only. So that's a one best case you can think of, and each time you otherwise you can simply find out what would be the absolute difference. That's how you can ideally this logic should be here. Okay.
Mm.
Now now what is happening? So the min and max we keep on finding out in n times, so which is causing the issue. So that I need two data structures. One is to give the minimum value in constant time. Other is to give the maximum value in constant time. Right? So is there anybody can do that? So one is heap. When you go with heap, you will have min heap, so which will return the minimum value in constant time, and you will also max heap, which will return the maximum value in constant time. So as we don't know heap data structure, so let's pause sometime. Now what is we can solve with heap, but as we don't know, so let's pause sometime. So what is other data structure you could think of?
I mean, if we go with our array DQ, there also we can do the same, right?
Don't worry about DQ. DQ is not simple how we did earlier. It's not like
Okay.
that. Uh, what is other data structure? To know min and max.
Data structure, like in simple array,
But again, it leads to same thing, right?
same order of n column. Yeah.
But you need somewhat efficient data structure. Have you tried all the solutions, Ajay? The problem.
Can we do this? Like, can we take a DQ and in that itself we'll keep on insert, like we'll take two
I am
DQs,
telling don't use DQ. Without DQ,
DQ at all.
what you could think of? Because if you go to DQ, right, handling is becoming very complex. Uh, you will get to know. It means what? To know min and max, what do you need to do? Sort only, right? So first value is the
But
minimum
that,
value, last value is the maximum value, right? But if
yeah.
you want to sort every time, it's like too much, right? So it becomes n square log n, because for
Yeah.
every n element you'll sort it. So if you don't want to sort it, but you want to know minimum and maximum value, is there any data structure you could think of?
Uh, Tree map,
Yeah. Why tree map? Why not tree set?
because we are going, if trees are basically things will be in a shorter order, if we go with the map, it is easier for us to get the min or max
Even tree
value,
set also gives the same, right? Tree
but
set
not in a
also.
constant time.
No, tree set and tree map both are
Trees are
same.
same, yeah, yeah,
Both are
correct.
same.
Why with tree map we can get it, tree short we cannot get it?
Can you tell me why?
Because in the tree map we can keep the elements in the order where it can be in a shorter order we can keep it, and we can keep this minimum one at the beginning and max one at the end. That way it would
Preset
be easy
also
for us
does
to
the
fetch.
same. Preset also does the same.
Okay.
What is the ask? We need to know the max length, right?
Correct.
So how do you know the max length?
In case of if you take with the if you go with the tree map approach,
Okay,
we
you
can
have
get the
min
first
value.
element, last one.
You just have min value and max value, and somehow you
Mhm.
figure out this is less than or equal to k. Now you need to
Okay.
find out max length. How do you find out max length?
In case of tree map, we can do that by get the first key and the last key, and the difference will give the limit. The difference we
I
can make.
understand that. So first key, last key, giving the difference as less than or equal to limit. Now you need
Limit,
length,
correct.
right? How do you know the length? In this case, if
Tree
you
map.
closely see here,
Mhm.
right? This is our
Mhm.
answer, right? In this case, max
Yeah.
value is 7, min value is 2, the difference is 5, so that the length is
Mhm.
what? 4. But how do you know the length 4?
How do we know the length is 4? The size of that map?
Because we have duplicate keys, no? Then size becomes.
Oh, what if it contains duplicate elements? So in that case, also tree map will take care of it.
Yeah, but you need length, right?
Hmm. How to maintain the length? No, I'm able to think of like how we can
That's where
get
you
the
need
length.
index, right? This is the index, right? So this
Yeah.
is the last index. So the difference between left
Right
and
minus
right,
left,
right
left
minus
and
left,
right.
right?
Yeah.
Yeah. So 5 minus 2 plus 1, so which is going to be 4. But what is the complexity you could see here? Okay, I definitely, you know, that you need to worry about the difference, right?
Hmm.
But it is very tough to manage through. So in the tree map, what do you want to maintain? So key is the value, right? Correct.
Yeah.
What is the value you want to keep?
Index.
If you keep index, what is the problem you could get? Tell me. Initially, first key is 2, and the
Hmm.
value it will store as 2. When it comes to last key, right, again 2, the value which will store as
Hmm.
5.
Correct.
Again, if you have some 3 here, then it becomes this one, so that it is 6 minus 5 plus 1, so the length going to be 2. But ideally, it should have this old one, right?
Yeah.
So that's where this is very complex analogy. So one thing for
Hmm.
sure, it's a combination of making use of data structure. Identifying the data structure is one thing. Second part is how to find out the how do you calculate the length, right? So that is second part. Somehow we figure out the data structure. Okay, perfect. So we figure out a data structure. So what we can do, let's apply a sliding window concept. So one thing for sure, I need to find out a valid window. When I pick up a valid window, let's say this is my valid window, right? So do you think this is my valid window? So this is my valid window. When I pick up a valid window, within a valid window, I will pick up the max value. How do you know that this is a valid window? In this window, I pick up a max value as 7, min value as 2, which is difference is less than or equal to 5. So it means I could say that this is valid window, but I can say that this is not valid window. How do I know this is not valid window?
Difference of min and max is going
Yeah,
beyond the
10
limit.
minus 1, so which is 9 greater than k, so which is 5. But I would say this is valid window because max is 4, min is 1, less than or equal to 3, less than or equal to 5. So this is valid window. But I would say this is not valid window. Why? Because I have in this window, I have max is 7, min is 1, which is 6 greater than limit. So this is not valid window. So it means I need to make sure that I always have a valid window for sure. Correct, nobody? I need to make sure
Yes.
that I always have a valid window. How do I know that it is a valid window? How do I know that if it is invalid window? Please.
Basically, we have to keep a track of the max or mean, and
Yeah.
if the
So if the
difference is
max
greater than the
minus
limit.
min, if it is greater than limit, it means it is invalid window. So that I need to make sure
Correct.
that it is going to be valid. So to do that, I need to stress the window. Correct. So let's see how can I do that. Let's see how can I do that. Let's move on. So what I'm going to do, let's keep it here. You know, buddy, this thought, right? If you go for DQ, you cannot get it.
Mm-hmm.
So that's why I told you to not to think about DQ.
Think of TQ.
These all Google level problems. Okay, so I'm having left is here, right is here. Okay, so one thing for sure, I need to take care of duplicate elements too. So that's why I go with tree map. So in the tree map, first I have what I'll do. as usually, right is always extending the window, left is always stretching the window. So left is here, right is here. So what I'll do, I'll take first element, so which is 10 and which is having count as 1. Okay, perfect. Now I'll go to the next element, right is moving here. So now I pick up the next element. Now if I see, when I'm here, right, when I'm here, so I have only one element. When you have only one element, you cannot make a difference, right? Even if you make a difference, the min and max become same element now. Yes or nobody?
Yeah.
So the
Difference is
difference
0.
becomes 0. So that there is no issue now. Now what I'll do, I'll move on to the next element, right? So when I move on to the next element, now if you closely see, I am not maintaining any order. So you can simply, I have value 1, so which is 1. Now if you see, in this case, the max I could get as 10, min I could get as 1, right? Correct, nobody? Yes or no?
Yes.
And here the difference is 9, correct?
Yes.
Now I need to make it invalid, right? Yes or
Yeah.
no? How do I make it invalid? I need to make sure that I need to stretch the window, correct?
Yes.
How do I stretch the window?
By moving left forward.
That's it. So now you have a left, right? Now take the left value. What is the left value? 10, right?
10.
Remove it from the map. Okay. So take the left value, remove it from the map. Okay, I removed it from the map. So then I will move the left furthermore. Perfect. Now in the map I
Yes.
have only what? In the map I have only 1. Correct?
Yes.
Correct now? So now again I will move right further. So let me move right further. So when I move right further, I forgot to maintain max length. So let's do that. Okay. So right now we got only 1 because that's what you get. Uh, so now because 10 minus 10 is 0, so 10 minus 1 is invalid, so that you have max length as 1. Now when you are here, right, when your right is here, so now take add the right pointer, so which is going to be 2 comma 1. Now what is the max here? 2, right? What is the min is 1, so it is less than limit 5, so that you found a valid window. So that the current size, how do you know the current size? How do you know the current size, current window size? You already know right and left, right? So this is the window, na? Yes or buddy? Yes or nobody?
Yes.
So this
Yes.
is the window, right? So that you can say right minus left plus 1. So obviously 2 minus 1 plus 1, which is 2. Current max is 1, so that it is going to be, max is going to be 2. Now what is our job? So as you have a valid window, so there is no point of stretching the window. It's time for me to move right furthermore. So I'll have 4 comma 1 now, because 4 repeated one time. Now if you closely see, the max is 4, min is 1, so which is going to be 3, which is still less than limit 5. Yes or no? Yes or nobody?
Yes.
So again you found a valid window, so that is time for you to update the max length. Now the max length is going to be 3, correct? Right minus left plus 1. So 3 minus 1, because right is pointing to 3, left is pointing to 1, 3 minus 1 plus 1, so which is going to be 3, correct? Correct, nobody?
Hmm. Yeah.
So I'm talking about indexes. Nice. Now it's time for me to move right furthermore. Perfect. So I need to move right furthermore. Now for the right is having value 7 comma 1. So max is 7, min is 1, which is equal to 6, greater than limit. So it's time for me to stretch the window, no? Yes or no?
Yeah.
So
Yeah.
I need to stretch the window. So that to stretch the window, what should I do? I need to remove the
Move the left point.
left. Okay, so
Left
on
forward.
the left I have 1, so I remove 1. Okay, so now left is moving forward. Now once I remove 1, if I find max is 7, min is going to be 2, then which is which is less than or equal to 5, so that I found a valid window. Now again calculate the length. Right is pointing to 4th index, left is pointing to 2nd index, so that plus 1, so again you will get 3, so there is no change in the max length. Is this clear, Ajay?
Yes. Yes.
Now let's move on to right furthermore. So now I am going to have right here. Now if you closely see, my right is holding value 2. So already 2 is there, so 2 comma, so you have 2 elements. Now if I go max, which is again 7, min, which is again 2. Now 7 minus 2, which is going to be 5, which is less than or equal to 5. It's time to calculate the length. So right index length minus, so it means 5 minus 2 plus 1, so which is going to be 4. So 4 is greater than 3, so you just get 4, return 4. Is that clear?
Yeah. Got it.
So that's so. For example, two is here, one is here, right? Then you could have get max length as 3 only. Okay.
Srinu, just a question. So when we are saying that the limit is, I mean, the difference is going beyond the limit,
Mhm.
you are simply moving the left one forward, correct?
Yeah.
We are not checking whether it is the mean or max. We kind of
No, no,
know
no,
that.
no, no. When until we, this is what I said, right? So whenever you find a invalid window,
Mm-hmm.
whenever you are finding a invalid window, what are you doing? Until you make that window as valid, you move left,
Okay.
right? In
Right.
this case, on the first
Right.
instance only it get valid. But
Huh.
if you closely see the same input, right? 10, 10 2
Basically, if we
4
duplicate that
7.
input, make 10, 10, 10,
No,
3,
no,
4
no.
times.
Let's see this one. So initially
Mm-hmm.
what you will have 10 comma 0, right? Then
Right.
max, min and max becomes same, so that max length becomes 1 because limit becomes 0, right?
Correct.
So here limit is 5. Then you have
5.
2 comma 1, right? So again the it is 8 now, difference is 8, so that obviously left is here, right is here. So obviously you move left here, so that this will go away. Now again you see that you will have only one element, so it min and max return the same. You are here, you get 0, there is no change in max length. Now if I move further, closely see, I am moving right further. So I am moving right here, so that now you have 1 comma 1. So min is 1, max is 2, absolute difference is 1. Obviously you can make it as 2 minus 1, which is 1, less than or equal to limit. It's time to calculate the length, so which is 2. Now let's move
Okay.
further. Now when I go further, so which is going to be 7, right? Now
Mm-hmm.
this is where you need to observe. So 7 comma 7 comma some index 7 comma 1. Okay, so
3.
no, we are not storing index, it is
Oh,
a counter.
sorry, we're skipping counter.
Yeah.
Huh?
Now
Huh.
if you see min is max is 7, min is 1, so which is 6 greater than 5. So it's time to
5.
remove the left value. We need to make this window
Mm.
valid, right? Left value is 2,
Correct.
right? So 2 is deleted. So left will move here. Now again if you closely see, min is 7, max is 1. So again 6, so greater than 5. So that I need to remove the left value. So left value is 1, so which is removed. Left will move here. So now this is the valid window, correct? Correct now.
Yes.
7 is the valid window. So left and right. That's what I'm saying. So until you make the window valid, you don't move right. So now again you move right here. So which is going to be 4 comma 1. 7 minus 4, which is 3. So valid. So you get 2. Now when I move right here, so it is going to be 2 comma 1. Now again you will have 7 minus 2, which is 5, less than or equal to 5. So that this is our valid window. It becomes 3.
Valid window.
So it
Mm-hmm.
means you need to move left pointer unless your window becomes valid, right? So and once you got a valid window, find out a max length and update it. So what is the time complexity here?
Order of n.
But you keep on adding data to the tree set, right? Tree map, right? You are adding data to
Yes.
tree map, right? So what is the cost of the element?
Addition to the tree map.
Yeah. So it
At
is
max, we
log
will be
n.
adding all elements. Or,
Yeah. You will be adding all the elements, and each element
yeah,
cost is what?
log n.
Yeah, so it means n log n, right?
Mm-hmm. For n elements, correct.
So in if the complete window is valid, your tree map end up having all the elements, so it is like n log n. So what is the space complexity?
Order of n.
Yeah, because the tree map has the complete
N
data,
number of elements.
right?
Mm. Shinu, one question. It might look like stupid one, but still I'll go ahead and ask it. So when we have this tree map, instead of tree map, what if we use a simple hash map where the key gonna
But
be
hash map
value?
doesn't sort the data, right? How do you know lowest element and min element and max element?
In this case, to know the lowest and highest. Oh, right. Yeah, that is
In
the core reason why we
Yeah,
selected the tree map.
yeah. If you go with
Got
the
it.
hash map, on an average it is constant, but tree map it's not like that because it sorts the keys.
Mm.
Right?
The benefit we get here is that the lowest and the highest one we can pick in constant time.
Hmm. Yeah.
Got it.
Ajay Akash is here.
Nice.
He's attending live session.
Live sessions.
This is very good problem, right?
Yeah, this is a good one. At least we can think of what needs to be done.
So what I'm saying, so first you will add current right value to the map, right? So how do you know that? So map dot, so you can take current number, so which is nums of right, and map dot put of num comma, so map dot get or default
Yeah,
of num
0,
comma 0
plus 1,
plus 1.
plus
Right,
1.
so it's time for us to get the last key and first key, correct na?
Hmm.
So as long as your map dot last key, you will return the last key, and it means it is max value. Map dot first key, so which is min value. If it is greater than limit, it means it is invalid na? Yes or no, buddy?
This cylinder. Yeah, then we need to move the left one forward.
It's not blindly. First you need to delete it from the map, right? Correct?
Map, yeah,
Map
correct.
dot get of nums of left. You will get a old
The key. Old key.
old element, you can say, which is to be removed, right? Old element
Correct.
count, actually. It's a
Right.
count, right? So old element count. So if it is, if this is very critical. If it is 1, right, you can blindly delete it. Otherwise, it will. If it is 1, count is 1, so you can delete it, right? So if you don't delete, that will come as a min element for future. So
Correct.
if it is not equal to 1, if it is greater than 1, so then we will just decrement and add.
Decrement the counter.
Yeah. Put off nums of left, comma, you can say count. Count minus 1. Done. So
Correct.
finally you will just decrement left plus plus. You will increment the left. Okay. So this always be true. So once it is done, it's time for me to find out the max length. Right?
Yeah.
Map dot max of max length. Right minus left plus 1. Done. Finally, done max length. Is it clear?
Yes.
Code seems to be very simple, right?
Yeah, if we use the right data structure.
No, the best thought. Actually, I'm happy that you told me that we need to find out max element and min element. Find out the difference. That's it. It will figure out the solution, right? So now, how do you optimize it? How do you optimize it? 10 to 174.
Basically, we have a complexity of order of n log n. We're trying to make that linear.
One thing for sure, how do you want to one thing you are clear that I can maintain the window using 2 pointers, right? Right? Within that window, if I am able to know what is the minimum value, what is the maximum value, then I can find somehow I can find out a length, right? Yes or no? Then how do you want to do it? Now tell me DQ. So from starting you are saying same, right? Tell me how do you want to do with DQ? First of all, is it possible with single DQ or do you need 2 DQs?
As I can think of is in DQ we cannot do this kind of getting the minimum max in a single one. So I was thinking if we can maintain 2 DQs.
Perfect.
One will hold the min and other will go for the max.
Okay, so one is min DQ, other is Max DQ. Okay, perfect.
max DQ.
Then how do you want to go with it?
So basically, in the max DQ, what we'll do is we'll keep the all like the maximum element at the beginning
Mm.
and keep the rest after that. Whereas the minimum DQ will keep it's in the increasing order basically. Keep the
Mm.
smallest one at the beginning and go for the
And how
maximum
do
ones
you
after that.
maintain the window? This
How
doesn't
do you
give you the
maintain?
length of a valid valid window, right?
Yeah, I mean from the single DQ we cannot get it, but if we do if we peek into that
With two DQs, you can identify which is valid window, but we need to find out length of the valid window. Now, how do you want to do that?
oh correct. How do we get the
Again, same left, right. Okay.
yeah, yeah.
So first you have 10 here. You're also having 10 here. Perfect. Right? The difference, max value you get from here, min value you get from here. Correct? The
Correct,
difference is
correct.
0. So because so that the max length is 1 now. Now right is here.
Mm.
So now you see the min DQ will maintain the minimum value, right? So that you remove the max from here. The max DQ
Mm.
will keep the max value first, so that max value is here. Now you see the difference,
Mm.
right? The
Mm.
difference is 8 na? Yes or no?
Yes.
10 minus 2, which is 8. Now it's time for me
Correct.
to test the valid window. So this is not part of Q. Now only you have 2 here. Here you have 10 comma 2. Now you need to test the window, right? Now it's time to move the left pointer. So when I move the left pointer, so I have value 10. So 10 is not present in min DQ. 10 is present in max DQ. Delete it. So once you delete
Mm.
it, now again you have the, now left is here, right? So left is here. Now you see the minimum difference between those two, which is 0. So obviously, because here you got 2, here also you got 2, so difference is 0. So you will have max length as 1 again. Now it's time for me
Mm.
to move the right pointer, right? So let's move right here. So what I'll do, I need to keep 2 here. So sorry, so earlier you have 2, right? Earlier you have 2. Now I am moving right, so right is having 1. So min DQ will have the min value first, right? So this will remove the 2 which is greater. Now on the max DQ also I will add, so 1 is smaller than 2, so that this is in right position, so you will keep it. Now you see the difference. If you see the difference, this is what my DQs contains, right? If you see the difference, 2 minus 1, which is 1, which is valid, so that length is going to be 2, so 2 will be here. Now when I move right here, so definitely I will have 7 here. So that you see current value is greater than 1, so that there is no change. Min DQ will maintain in minimum value first. Now when I come here, right, in the max DQ current value is 7, so which will delete all the previous values, so that 7 will be at DQ. Now if you see the difference, 7, I will remove this, 7 minus 1, so which is 6 greater than 5. So it's time to test the left window. So in the left window, if you closely see, in the left, this is what I am trying to say. This is what my first DQ have, this is what my second DQ have. Left is pointing to value 2. So 2 is not present in both the DQs, right? So there is no point
Correct.
in deleting it. So now you move left further. So now left comes here. Now left is having value 1. So 1 is here. So that 1 is present in min DQ. So that you can delete 1 from min DQ. Now you can move the left further more. Now left is so now if you closely see the difference between these two, which is 0, so you will, so now you have valid window, so that there is no point of considering the current left, so it's time to move the right. Correct na?
Yeah.
So same logic I am just applying on the DQ. Now right is
DQ.
having 4, right? So 4, so this will remove 4, so 4 will present here. Now 7 minus 4, which is 3, so valid. So find out a well length, which is 2. So 2 is already there. Now again move to right. Now again you will get 2, so which will remove 4. And here also you will have 2. So again you will have max is 7, min is 2, 7 minus 2, 5. So which is less than or equal to 5. So that you can consider this. The current length is 3, so 3 will be updated. So that is your answer. Correct?
Mm. Mm.
So what is the time complexity here?
Order of n.
Right, order of n. So what is the space complexity?
Order of 2n.
Do you think it is 2n?
Because of the,
Yeah, yeah.
sorry, on the order of, basically because of two DQs.
But do you
But
have
at
all
the
the
time,
time n elements in both the DQs?
no, both will not contain 2n. Yeah.
Do you have half elements in both the DQs?
Half elements, yes, 7, 4, 2 at least
No,
it
no.
can
If
hold on
one
to.
queue becomes empty means other queue holds those values. Because it's a min and
Correct.
max, right? So that always it is going to
Yeah.
be n.
And
It's not n by 2. Right?
mm.
So this is very smart solution on DQ. So one thing for sure, I need to go with two queues, two DQs, right?
Mm.
Min DQ.
And you can max DQ.
You never feel like these are queue problems, right?
Yeah, from the day one, you cannot feel like that, but I mean, when you think of queue, we think like, okay, with one queue, how can you solve it? But when you think of two queues,
Yeah,
then definitely this problem can be solved.
yeah. Yeah, so this is my right current number. So what can we do? Simply, first we will add to DQs first, so that you can avoid empty checks.
Okay.
Right. Okay, so you don't add it blindly, right? Correct? You don't add it blindly, right? So take the current number. So this is my current number. What I will do, as long as your min DQ is not empty, and whatever last element you get, right? If it is less than this number, not equal, buddy. Okay, we should consider duplicates. So we just remove last element. Correct? This is what we did, right? Similarly,
Correct.
similarly, it can be part of other end also. If it is max DQ, yeah, in min DQ, if the last element is greater than current number, then you delete. In max DQ, if the last element is less than current element, you will delete from the max DQ. Correct? This will have
Just
maximum
one.
elements. This will have
Yeah,
minimum elements.
max will
Right? So
max will delete the last element.
yeah,
Less than, yeah, correct. If it is less, then we delete it.
yeah.
Correct.
So it's time for us to add both the queues. Add of number and max DQ dot add of numbers. Once you add this, what is our job now? So we want to make sure that it is going to be valid window, right? How do you know that it is valid window? So in the max DQ, you get the first element, get first, minus in the
Minus
min DQ,
min
you
DQ.
get the first element.
First, if it is greater than,
Yeah, so if it is yeah, so if it is greater than limit, so it means it
limit.
is invalid, so that it's time to remove it, right? But the, whatever element you want to remove, that is the left element, right? You need to stress the left element, so that you need to see if nums of left is equal to max dq dot get first, then you just need
Get
to remove
first.
that. Right, so max dq dot remove first, correct? Similarly,
Yes.
you need to check for nums of
Min
left
DQ
min
also.
dq. So you need to delete it from min dq and just do left plus plus. And finally, you will get a right window of left. So finally, what is your job? Your max length is going to be math dot max of max length right minus left plus 1.
Plus 1. Yeah.
You know where I struggled lot, uh, in this solution, where I struggled is uh, maintaining of left and right pointers. Getting that thought is more critical. So this, we can find out somehow what is it is valid or not. But to find out a length, right, you need one more pointer as left. So we only think of right, and it's very tough for us to calculate the length. Correct?
Right is moving like in a loop only.
So
Left
this
is the one
left,
which we voluntarily move
left,
forward.
yeah. So that through that only you can make it is valid and find out a valid
Valid.
one.
Correct.
Yeah. So let's move on to other problem.
This is a good problem actually.
Hmm. If you solve these kind of problems, right? So you know what is going to happen down the line when we are looking on different problems. On a single problem, we think about multiple data structures. So
Correct.
it's like a revision too.
Mm-hmm.
Okay, this is a nice one. Okay, so it is reverse body. So we need to find out shortest subarray where sum is at least k. It's not the same problem, but it is a different problem. So let me note down. So let's say you have a data something like this. Let's say you have a data. Earlier problem is what is the problem number? 1438. Okay. So this one is 862. Okay. So let's say you have a data something like this. Let me take somewhat best input 2 minus 1 plus 1 and 2. Okay, so you have a data something like this. Let's say k equal to 3. So we need to find out shortest subarray length where sum is at least k, right? It means greater than or equal to k. So what is the shortest subarray where sum is greater than or equal to k?
I think the last two elements, one,
Right, so
two.
1 plus 2, which is greater than or equal to 3, so which is going to be 2. You could also find this one, so 2, 1, 1, 2. So here the sum is 4, which is greater than or equal to k, but here the length is 4, but he is expecting shortest subarray where sum is greater than or equal to k. How do you want to solve this?
If you take a brute force where we can take two loops,
Yeah, so the brute
keep
force is what
managing it.
you will keep on. Yeah, the brute force solution is dead easy. So you will find a subarray cost, and if it is greater than or equal to k, then you will simply get the min length, right? Correct.
Hmm.
So if you
Correct.
don't find anything such, you can return minus one. That's what
Return
he's saying.
minus one.
I think here 1 2 k equal 4. You didn't find anything, so minus one. Uh, yeah, so brute force is very easy. So you can come up with n square. Possible subarrays you can generate, and sum is equal to 3. Then you can simply return that. Mm. Yeah, what could be other solution? Okay, in a brute force, what are you doing? In a brute force, what are you doing? So first you got 2. Okay. So first you got 2. Okay, 2 is not equal. Then you got 2 minus 1. Then 2 minus 1 plus 1. And 2 minus 1 plus 1 plus 2. Here I found 4. So which is greater than or equal to 3. I consider this minus 1 plus 1, right? So which is valid length. So I consider 4 as length. then minus 1, then minus 1 plus 1, then minus 1 plus 1 plus 2. So some none of the cases I found greater than 3, so which I didn't consider. Then 1, then 1 2 I found 3, so which is greater than or equal to 3, so I found this. Then again 2, then 2 is not, then finally 2, so which is not, so I'll just ignore it. So this is where I found the valid length as 2, so 2 will be returned. Now what is the better way you can think of? This is a brute force, right? So in the brute force, uh, yeah.
So basically, we are taking a bigger window and then moving the left one forward to make the window smaller, as well as trying to get a sum where the sum is greater than equal to k.
Okay, so you are saying this way, right? Let's say,
Yeah.
mm, let's say you have left is here, right is here. Here the value is 4, right? Correct? So you got the length
Yes.
as 4. Now you found a value which is 4 is greater than or equal to 3, so it's time for me to move left. So when I move left,
Mm.
so 4 minus 2, so which is what? 2,
Two.
right? So this window
Mm.
length is 2, and which is less than 3. Now you understand that, you think that this is valid window, right?
This is not valid, right? Because the sum is less
How do
than
you know,
2k.
that this length we should not consider?
Because from the total sum, what are the previous
Then
sum was that 4,
perfect.
we did a minus of the,
One thing
yeah,
for
the
sure,
moving
this
in.
length is not considered, right? But do you need
Correct.
to move left or not to find to find smallest window?
If the sum is greater than k, then we will be moving the
But
left
in this
forward.
case, sum is 2, right? Sum is 2, which is not greater than k, so that you don't move left. But if I move left only, I'll get a valid window.
Hmm. Because that array can contain negative elements also.
Yeah, that's the
So
tricky part.
we have to move left only, yeah.
So this doesn't work, right?
Yeah, true. It's difficult to know
Now,
which one to move.
yeah, now if I closely see, this is what we think of, right? This guy. Yeah. So this is what we think of, right? Now, how do you know that this is valid without? How do you know that this is valid? This part is valid for sure, right? How do you know that that part is valid without traversing completely? With single traversal, I should know. Now, on constant time, I need to know this part. This part is valid.
Hmm.
So that way, that's where you need to. You will get a valid result.
Hmm. What if we maintain a prefix array,
Perfect, man.
uh,
Prefix array.
which will,
Let's say. Mm,
yeah, which will keep track of those elements?
mm. Okay, perfect. So one best solution is prefix array. Okay, it needs further
Hmm.
optimization. Let's think about it. Nice, very
Hmm.
nice idea. So let's move on. So prefix array. So one is two. So this is my prefix array. Prefix sum. Okay, you can say prefix sum.
Correct.
So you get two. So 1 is 2. Then it is 1, right? Correct? 2 minus 1 is 1. And 1 plus 1, which is 2. And 2 plus 2, which is 4. Right?
Hmm.
Correct? Na?
Hmm.
So till that element,
Yeah.
what is the prefix sum you could think of? Now, 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 if I want to know this part is valid, right? How do I know that this part is valid?
How do we know that part is valid?
Assume I am at this element. I am at this element. I am at here, so when I am here, I know that the prefix sum is 4, right?
Correct.
But I need to get
Yeah.
the shortest one, right?
Yes.
To get the shortest one, how do I know that this is valid? So if you see, this is 0, 1, 2, 3. So this is index 3 prefix sum.
Correct.
If I blindly go, it is 4, right? But I need to know somewhat, is there, can I make a shortest other than length 4?
Yes.
First of all, you have a maximum sum, right? Yes or nobody? Here,
Hmm.
you have a maximum sum greater than or equal to 3, right?
Correct. Yeah.
To get most valid value, most means this will return the count as 4, right? Because you have 4 variable.
Hmm.
I want to know
Hmm.
smallest value. I want to know smallest array other than 4, and still this value, this condition should satisfy. How should I go with it? Do you get my point?
Yeah, I got your point.
I
Basically, we
need to,
already have a maximum sum, possible sum.
I have
We're trying to
maximum,
find.
yeah, I
Yeah.
have a maximum sum, and I need to find out next smallest maximum sum.
Yeah.
Okay, I need to find out next smallest maximum sum to satisfy this condition. How do I know that? I am at last element. Before that, I have couple of elements. Come on, come on, come on.
Thinking.
No, so it means I have a current 4, right? What is the
Yes.
next smallest possible sum satisfying this sum? This value, which is 3, right?
Yeah.
Right?
Maximum
Which is
possible is
3.
3.
So it means I should not consider other prefix sums, right? 2, 2, if I consider 2, 2, definitely it will fail, right?
Hmm.
If I consider 1, it will pass. Right? This is prefix sum now, buddy, please.
That
This
is
one is
prefix sum.
prefix
Yes.
sum. This one is prefix sum till index 1, right? So
Yes.
somehow if I maintain min heap on prefix sums, min heap on prefix sum. Okay, so it means initially you have prefix sum as 1, which is at index 1, correct? Prefix sum
Correct.
as 1, which is at index 1, and prefix sum as 2, which is at index 0, prefix sum as 2, which is at index 2. Now you also have prefix sum as 4, which is at index 3, right? Now you have
Yep.
prefix sum as, current prefix sum is 4, so 4 is greater than or equal to 3, so condition is true. You found the valid answer, which is 4. Now what I will do, I want to find out next possible solution, so that I will try to get what is the smallest prefix sum which is already accumulated. This is the smallest prefix sum which is already accumulated, right? I am at index
Yes.
3, so index 1, you already have a smallest prefix sum, so I take that. Okay, so 4 minus 1, which is 3, which is greater than or equal to 3, so which is valid.
Hmm.
It means if I don't include this till this index also, it is valid. Correct, nobody, please? If I don't
Yes.
include this index also, it is valid, because when I subtract this value, it means you are subtracting this part of the array. Correct?
Correct. Correct.
So you are eliminating this part of the array, so this part of the array is valid. It means current right pointer is at index 3, correct? Right pointer is at
Yes.
index 3. So it means if I am at index 3, so I got a valid value, so which is 1, so it is at index 1, so I take that index 3 minus 1, which is going to be 2, so this is my answer. Correct?
Correct.
You understood the concept, right?
Yeah. Concept I understood. Yeah.
Now how do you, now you don't know min heap, right? So min heap always, so one thing for sure, you need to know the prefix sum plus on which index this is this is having prefix sum. So that's why you need to know the prefix sum and on which index it is present, so that you can find out a minimum length based on that index, current index minus the popped index, so that you will get the length, right?
Hmm.
Now, as we don't know min heap concept, so let's not think about it. So later you will solve all these problems in min heap or mac once we learn min data structure. And what is other data structure you could think of? Please, buddy.
Other one, yeah, just like the previous one, we can take the same, like we can take a DQ,
Array, why are you
and with
going
the
to
peak first
DQ?
and peak last, we can get the mean and max.
No, no, why are you
Not
going to
possible.
DQ first? Again, I said, right, it is somewhat, don't get into DQ directly,
Okay.
because there are a lot of conditions involved in it, right? How do you know that?
Hmm.
What is it, buddy? Tree map, na?
Same tree map.
Correct.
Mhm.
Okay, let's see the tree map. If you go tree map, what will happen? You will always get the smallest index, right? Smallest index, smallest value, smallest prefix sum. What if prefix sum is duplicated? So that's where you will have a value. So in the value, what do you keep? So this is tree map, right? So you will have key and the value. So in the value, what do you keep?
In the key, we'll keep that sum.
Mm.
Uh,
In
yeah,
the
key will
value.
basically contain the prefix sum.
Mm.
Value will keep that index till that until we get whatever the sum we got. So, for
But
example,
if
for
the prefix
index
sum is
0,
duplicated, then do you get a chance of prefix sum is duplicated?
yes, possible.
What if you have 0 here, then you will get a duplicate. So if you have 0 here, so
Yep.
you will get duplicate prefix sum. In that case, which one you will consider?
Right. Prefix sum also can be duplicate.
So
If
you
you
will
get
have
duplicate
multiple indexes,
value,
right? So you will have multiple indexes so that you will maintain a list, right?
yeah,
List of
yeah,
indexes, right? Correct?
list of indexes, correct. Correct.
Now, which
Correct.
index you will consider to get the best result?
The first possible index, like at the zeroth index, which would be possible at one first.
That will give you long length, right? If you consider last index, which will give you short length, no? Yes or no, buddy?
If you consider, just a minute, if you take out the
For
last
example,
element,
let's say you have 0, 1, 2, and the current index is
hmm,
somewhat 5. You got a valid value.
hmm,
Then which index
hmm,
you consider 5, 0, 1, 2 to get the shortest length?
we consider two.
Last value, right? So that's always give
Yeah,
shortest length. Correct?
shortest one, correct.
So that's why
Correct.
consider last value. Okay?
Got it.
So now I think I don't need to write explain anything. So what is the time complexity now?
Order of n log n because of
Mm.
tree map.
Yeah. So what is the space complexity?
We're
Space
just getting a
complexity.
number counter.
No, on tree map you are maintaining prefix
Sorry.
sum, right?
Yeah, for tree map, for tree map we will have space, correct.
And what is the best? What is the? Yeah. So okay. So I think this is fine, but it is not. It always be n log n.
Okay.
We can improve this also,
Correct.
but through tree map you can't do that. But that's fine. So let's implement it. So what
Yeah.
are the things also we should consider now? So one thing for sure. Uh, Yeah, so one thing for sure, so this part we should consider as long as minimum element, uh, minimum element and current sum is satisfying the condition, you take that length and you remove the minimum element and look for next minimum element. Correct, na buddy?
Hmm.
So look
Correct.
for next minimum element. No, you don't need to look for next minimum element because you already, yeah. Let's see, buddy. So let me write the code. Even I also didn't solve this problem. Let's see. show trim of integer, list of integers, map. I got one more thought, but let's see. If this doesn't work, then we can think of it. Okay. Let's move on. Right less than unstart length, right plus plus, and we need a min length, right? So this is min length, which is integer dot max value. Just a second. So, do you necessarily need to maintain prefix sum array, buddy?
Prefix sum array, we can directly insert into the
Map,
tree
right?
map,
So,
right?
because this index will take
Yeah.
care of that, right?
Take care of it, yeah.
So, what is our job is, yeah, so this is my current running sum. So, this is my running sum. So, which is actually works as a prefix sum. So, running sum plus equal nums of right. So what can we do? We will see. So map dot get or default of given running sum, correct? And new array list. Correct. So new array list. Then what can we do? We'll get that list. What is our job? So list dot add of current index, which is to be added, and again you will put this into map with this running sum. You will add the current right pointer, correct? Correct, nobody? So now it's time for us to find out a valid window, right? So to find
But
out a
you know,
valid
at line number 12, when we are putting it, that second one would be a list, right? Not a single.
Yeah. So now we need to find out a valid window, right? Then to make it is valid window, first we need to remove the invalid elements, right?
Yes.
Yes or no? So
Yes.
how do you know that it is invalid? So if the current sum, right? If the current sum, and so generally when do you say that it is valid window?
When the current sum is
minus from the map, once you get a first key, right? It is going to return the minimum value, right?
Correct.
If it is less than or equal to k, then it is valid window, correct?
Yeah, correct.
So
correct.
if it is greater than k, means it is invalid window, correct?
Invalid window.
Then I need to remove that, right? Yes,
Yes.
or no? So I can get that what is min value map dot first key.
First key.
Or min, you can say. So if map dot get of min dot size, which is equal to 1, you can directly remove, right? Yes or no, buddy?
Yes.
That will return key. Otherwise, what you can do, I'm directly writing it. So map dot get of min dot remove of. Okay, so you will get a list here. Better let me write it as a single code. So list of integer indices dot get of min. Right. So if indices size is equal to this, you can directly remove. Otherwise, indices dot remove of indices dot size minus 1.
Minus 1. Basically, removing the last element.
Or do we remove everything? Is it okay to remove everything?
I mean, yeah,
Because
if you consider the
because
sum,
this
then
this will this will satisfy for the next one also, right?
hmm,
Yes or no? So there is no point in maintaining it. So you can remove everything, right? What do you say? Because if I remove now, next time also it will give the same, right? First key same element, right? If you have duplicate indices.
hmm,
Yes or no, Ajay?
yeah, yeah, for the same key, it will give you the same
So
result.
what's the point of maintaining a list of integers? Rather integer. Okay, let's do. Yeah. So what's the point of maintaining list of integers, right? Correct.
Yes.
Let's improvise this. Okay, let it be. Though we know that is dead code, let it be. Now once you get a valid window, then definitely you will have a yeah. So you will have a yeah. So first thing, let it be, bro. So I think this will work. So you don't have to maintain the list. Why? Because you don't need it, right? Yes or no? Or do you want to keep it?
For now, let's keep it.
But at the end, you will definitely you don't need this. Okay, so we can optimize it. So you will get indices, and
Hmm.
what is our job? Uh, last invalid index, because I need to know, right? Yes or nobody?
Yeah.
Which is going to be initially current, right? But you can make it as last invalid index equal to indices last index you can consider, but this is very bad, right? So you can blindly go with one. Then you can remove map dot remove of min. What else? You can also consider min length. So min length equal to map dot min of min length comma current right. So this you can avoid actually. So current right minus this one. Okay, so you can delete old ones. If you delete old one, next one can be the same. You don't know that, so that this one you will keep. This is the last one, so which is valid. So that next one is the valid thing. So that you can simply consider this. Correct, na?
Yes.
So done. So we were done with min length, and finally, what is our job? Return if min length is equal to integer dot max value minus 1,
Minus 1.
otherwise min length. Let me think of it. So if it is greater than, okay, it is less than length, right? So invalid means if it is less than k. So because we need at least k na, so that if it is less than k,
Hmm.
it is invalid. Next one is valid, so that you can consider that. Let me run it. Hash map, tree map. And no such element exception on a map. Why? Because we are not putting into map, is it? Hmm. Yeah, definitely it will delete all the time, right? So if it is greater than or equal to k, then you will get this. then you will remove that and find out next one. Let me run that. 1 1. Okay, so running sum is 1. Yes, this is good problem. 1 minus 1, which is 0. So this satisfies, this thing will not satisfy. Okay, this is running sum. Let me remove invalid things. Let's think 2 minutes.
Sure.
We wanted to eliminate invalid keys. Once we eliminate invalid keys, somewhere you will have last invalid key here, and here we want to consider. So if I wanted to consider this one, then what should I do? Or how is it working? Always it is giving -1, so that is wrong. So yeah, if I keep the same, what will happen? Let's see. Go see chat. What I did, so this is valid case, right? So all the time I try to find out valid case. So somehow I find out, and in edge case is if current running sum greater than or equal to k, then this is, I think it is failing for edge cases. So let me try max length comma right +1. Yeah, it's failing for edge case only. Let me think, is there anything wrong I could see here? It was failed for I told you now, bro. So this is it is failing for logic
Duplicate
is
negative
correct.
numbers.
No, it's not about wrong answer. Okay, it's wrong answer for 1k. What is okay, let's make it long because all are higher values, right? And
Yeah.
it took maybe this could be problem with long.
Yeah, long. Yeah, correct.
Now anyhow we don't need to worry about maintaining list of integers, but let it
Yeah.
be. Where is this guy long? Does it give anything wrong? Int cannot be converted to long. Okay.
Yeah, that one also need to convert it to long.
Long. Where is this guy? 0L. Yeah, it's a problem with long only. Accepted one. Perfect. But what I would suggest, you don't need to maintain the list, right?
Yeah.
You don't need to maintain the list. Why? What is the point in maintaining the list? There is no point. You can
So
always
basically, whatever the
blindly.
result we get, it's gonna be the with the longer queue only, so longer list only.
As you want to know shortest length, right? So that latest one
Yeah,
is going to be your answer now. So
correct. Let us know that answer.
that's where you can avoid this.
19th number line. Yeah.
Yeah, somehow we were correct conceptually, but writing the code
Hmm.
somewhere we missed it. This edge case we missed it. That's the first one.
Hmm.
But other things are conceptually good. Let me see. Yeah, so that in pages. Indices dot get of min. What it is going to return? What is the problem it is saying? Indices is invalid. Yeah. Map dot get of min. So that's let's see what's the improvement. There is no improvement. Uh,
But
but can you think of DQ for this, Ajay? Or shall we discuss?
mm, so basically, we have to maintain in the DQ the possible list of prefix sums.
Mm.
No, I'm not unable to think how
Just
can solve it with DQ.
1 minute ago, I got a call.
Okay.
Yeah, okay, done. So how do you think of DQ, right? So let's think about it. So what are we doing here? Then how do you optimize it? So the major problem we could face here is finding the minimum sum, right? Finding the
Mm.
minimum prefix sum, right? Uh, that's where it gets into log n. I think it is somewhat easy to solve. Let's see. Minimum sum, if I'm able to do that in DQ, then my problem is solved, right? Yes or nobody?
Mm.
It means if I have a maximum elements, uh, I will hold it back. If I'm
Mm.
having a minimum element, then I will
That should be at the front.
definitely remove it.
Mm.
Okay, so I'll definitely remove it. So if I do that, what if my deleted min is the valid answer? In this case, what are we doing? We are doing the same thing, yeah. So let's go ahead with it. So what we do? So we will go with the DQ. You can say DQ of min, right? So initially you will get running sum as 2. This is running sum as 2 with index 0. Now let's move on to next pointer. Obviously current running sum is 2 and 2 is not equal to expected k is 3, so which is not valid, and dq also in empty initially, so that there is no point. then you will get current running sum as 1, and which is at index 1, so running sum becomes 1, and 1 minus 1 0, so which is not greater than this. So definitely this is not valid, which is not greater than or equal to this is not valid. So now let's move on to next one. You will get 1 plus 2, so which is equal to 3. Earlier it is 1, right? Okay, let's take earlier input only. This is 1. Okay, so 1 plus 1, so which is going to be 2. Now which is not greater than k, so that what you do, so you will just add 2 again. 2 comma 2. So when I am adding 1, I will delete this, so that dq will have 1 comma 2. Okay, so this is how it is. Now when I get next element, so plus 2, which is going to be 4. Now if I see I got this, so first one I'll update this to my min count is to 4, then I will see is there any possibility. So 4 minus 1, which is also 3, which is greater than or equal to 3, so that I will calculate current index is 3 minus 1, so which is going to be 2, so 2 is my answer. Now I look for next one, so 4 minus 2, which is not, so that definitely I will take this answer. Did I went very quick, Ajay?
Yes.
So the plan is earlier where we struggled to get the minimum value, right? To get the minimum values, that's where we struggled. So that's where the heap or tree data structure is giving log n complexity. So I want to minimize that log n complexity, so that what I will do, I will keep max values set back and min values I will delete. So let's do that. Yeah, min, yeah, smallest min. Okay, so let's do that. So initially this is my dq, right? This is my dq. So initially I am here. So current sum is 2, correct? Current sum is
Yes.
2, dq is empty, so that there is no change, so that I will just have dq with current sum as 2 comma 0. Now when I am here, the current sum becomes 1, right?
Yes.
Current sum becomes 1, and it is not equal to sum, which is not satisfying the principle also. I want to make my result as minimal as possible, right? So what I will do, if it is current sum is greater than the dq sum, then I will delete it. I will keep the current sum, which is 1 is at 1. Now when I am here, now current sum becomes 1 plus 1, so which is going to be 2, correct? Till now
Yes.
it's clear, no? So when
Yes.
the current sum is higher, so there is no point in interestingly what I'll do, I'll keep one more element here, 2 uh, 2 and 3 also, so that our things will be more clear. Okay, so now current sum is, I am here, so current sum is 2. Now in the dq, if I take the first element, okay, so the first element sum is 1, so 2 minus 1, so which is 1. So generally when do you say that it is valid? When do you say that it is valid? So when you pick up from, obviously the current sum itself is not equal to this, and if the current sum is not equal to even if you pick up the smallest value from that, still it is not valid, so that there is no point in it. So when you take the current sum is 2, and 2 is larger than the minimum value present in q, so that you just append this. Okay, so 2 is at index 2, so I will just keep it. Is this clear, buddy? Till here is it clear?
Yes.
Now let's move on. So now I am here. So when I am here, I got value 2. So again add plus 2, so which is going to be 4. Now 4 is greater than or equal to 3, so that it means you found a first valid thing, so that our min length is going to be current length. So current length is going to be what? You are at index 4, so which is going to be index plus 1, so you got 4. Now as you get a valid one, let's see, do you find further valid ones? Do you get me? So let's see, do you get smallest one? So current one is 4, so do you get a smallest one? So current length is 4, take the minimum value, which is 1, So 4 minus 1, which is 3, so which is greater than or equal to 3. You already have a index which is 1, so that current index is what? 3. You got the index as 1, so 3 minus 1, which is 2, so that you got a valid length as 2. Now which is minimum than existing one, so you will update it. So this will be deleted. Now look for next one. So 4 minus, next minimum value is 2. So 4 minus 2, so which is not valid. So that it's time for me to move further. So before moving to the next element, add the current element 4 with the value 3, with the index 3. Now when I move on to next element, I get 7, correct? Yes or nobody?
7, yeah. 7, yes.
Now 7 minus 2. 7 minus 2, which is what? 5. Correct? 5 is greater than or equal to 3. It means I can pick
3.
up this. So it means earlier 7 is at index 4, right? So 4 minus 2,
Yeah.
which is 2. So again, earlier also 2, so there is no change. Now this is deleted. What is the next min element? 4, right? Correct?
4.
7 minus 4, which is 3, which is greater than or equal to 3. So that I can pick up this index. So 4 minus 3, which is equal to 1. So 1 is minimum than this, so I will update 1. Now final answer is 1.
1.
So it's not about, so once you are able to write the logic of tree map, so then this should automatically comes into your mind. It's not a complex thing, right? Yes or no?
Yes.
So
Yes.
you want to minimize it, right? I don't know until it is executed. DQ of integer, min DQ, new array list. So what is our job? DQ of integer, we need both the values, right? So let's take value and index nowadays. So let's take
Index,
integer array.
yeah.
Or you can take some node, or let's take pair object. It will support key and value.
Okay.
So key is the value, value is the index. Okay. So this is my running sum. Then what is our job? Okay, so what is our job? So first of all, we will make sure that our DQ is always going to be minimum, right? So how do you know that?
Correct.
So I want to, let's remove this. So I want to make DQ is always going to be minimum. So what I will do, as long as my DQ is not empty. So first thing is, this is for first base case. If running sum is greater than or equal to what is it, k, right? It means you found
K.
a valid value. So once you found a valid value, so what is our job? So find out a min length, right? So min length equal to math dot min of min length comma current right plus 1, because it is starting from 0. Okay, one best way is you can find next valid value within this loop also, but in order to make it cleaner, so let me do that here. So as long as you are running sum minus on the DQ, first you check this min DQ, it is not empty. Empty. If it is not empty, and on the DQ you will get a first key. Now first key is the actual value, buddy. So DQ,
Actual value. Yeah.
And DQ dot get first will return the object, then get key is the value. So if it is greater than or equal to k, then you found a valid value. So that what is your job? So first get the pair of integer, integer, and then this is our pair, dq dot remove first. Once you do this, so what is your job? So you will just update the min length. Min length is going to be map dot min of min length comma current right minus p dot get value. Correct? correct number
Yes.
value is our index.
Index.
Okay, so that way you will just find out everything, and finally now you want to make sure that your dq is always going to be minimal, right? So what is your job now? Why, whatever current running sum, whatever current running sum, if it is less than, not less than or equal to, less than or equal to also fine. Yeah, anyhow it will be deleted here, no worries. So if the current running sum is less than
Okay.
then, yeah, not dq, right? If it
I
is
mean DQ, huh?
if it is less than dq key, before that you will just update this, then it's time for me to remove that. Get last, right? So last element, from last you will move on, no? From last you will move on.
Mm-hmm.
So min dq dot remove last. So once you've done this, finally it's time for you to add. This is going to be your either first minimum or the last minimum. So dq dot add of, you can just add new pay with the running sum and the index, correct?
Index, yes. Right.
So finally you will get it. Same logic, once you write one or two problems, right? I think I have
Mm.
declared wrongly. It's a linked list, right? Once you write one or two problems, this is nothing but this is very normal. I think while
Okay.
writing the pair, uh, you don't have to do that squares, I guess. Let's see, where is it? Yeah, class cast exception, long cannot be cast to int. Okay, what is our job now? Long.
Make it long. Yeah.
And somewhere did I copy anywhere? I think I didn't. I directly updated here.
The the pair is now we have right at line number. Go to code. Yeah.
What is
15th. Yeah.
cannot be converted? Yeah,
Converted, right? Yeah. Long.
yeah, that's how it works.
I mean, overall concept I understood, but yeah, with DQ, when they're writing the code,
No,
it's not super intuitive.
DQ is not something you can directly attempt because
Mm-hmm.
there are a lot of conditions, right? It is very
Conditions,
tough
yeah.
to maintain these conditions. If you are able to clear on the map, then you can directly attempt DQ. Arey, why fellows written better code? Let's look at their code. Yeah, this is what. Oh, it is DQ only. At that time, they could have smaller test cases, buddy.
Oh, okay. With time, there are
Or
more test cases. And
what they did, oh, they used array rather than DQ, and they are loading into previous index. Keep on moving. Head tail concept, you know. So tile is
okay.
the last element, head is the first element.
Mm-hmm.
Through array, they made it very complex, but it is always fine. DQ
Mm-hmm.
length, they took nums dot length, they are not required, but they were able to handle with integer, right? I think when they
Oh,
submitted,
yeah.
they don't have long data, or did they use any
Maybe.
intelligent logic?
Maybe we can take this solution, copy paste and run it. If it
No,
is
it
giving
will
the
work.
same,
So here, somewhere
you can
they
just
don't we have copy? Okay.
no, you can just drag it, I think. Yeah.
I'm thinking they are able to do minus operation, so that supports int. Let's see. So they are able to do minus kind of thing, right? Yeah. Or they are not using at all. They are not using any indexes here. They are only using indexes or what? It was very critical to understand, buddy. So the same concept. Oh, see, it went 99%. Same concept, but what they are doing, they are manipulating on the index, not on the value. That's what I'm thinking. You see, right and value, take direct value. Oh. Yeah. Somewhat critical to understand, but I got idea. I cannot debug that complete code, but I got what is the thing they wanted to do. Okay, it's a long session today, but we solved two good problems now.
See, the quality problem was really good.
This one I directly attempted, bro. I thought of which one? Today's latest one, right? This one, where is it? Did I try this one earlier? Shortest one. Oh, I tried earlier. When?
Not today only.
Everything is today only. Huh? Why we submitted 4 times? Huh? Okay. Today only. First time it went wrong. Good. Okay, buddy. So let's see tomorrow. Other one I tried.
Yes.
I think. Let's see. Do they give solutions? Maybe DQ they can map. DQ.
There can be multiple solutions with multiple data structures.
Do they come up with map? Monotonic stack plus binary search. It is different. What is this solution? It is heap. This is heap. Priority queue is heap. So the map solution we can solve with heap also. If we discussed with heap, then we solve with map, right? Yeah.
Correct. Yeah.
So same kind
We
of.
thought like heap is not it is like discuss the concept we have not discussed, so we skipped it.
Yeah, maybe.